Today we're looking at gravitational force, which is the force between two masses. Here's the formula. Fg equals big G m1 times m2 divided by r squared. Keep in mind that Fg is gravitational force. Big G is a universal gravitational constant, which is 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. And you might need to write that down because you're going to use that number over and over. It's always that number. M1 is the mass of the first object or body. M2 is the mass of the second object or body. And R is the distance between the centers of the two bodies. Keep in mind that whatever R is, you're going to have to end up squaring it. And if you're trying to find R, you're going to have to end up square rooting your answer. So here's the tendencies that we have. A smaller R is going to mean a larger force, meaning that it's inversely proportional. So if R decreases by a certain factor, let's say it decreases by a factor of 2, force will increase by that factor squared. So if R decreases by a factor of 2, then force will increase by a factor of 4. If R increases by a factor of 3, force will decrease by a factor of 9, so on and so forth. Larger mass means larger force. If mass increases by a certain factor, force will increase by the same factor. All right? So if I increase one of the masses by a factor of 2, force will increase by a factor of 2. If I increase both masses by a factor of 2, force will increase by a factor of 4, because each mass has increased, so you'd increase the force twice basically. Here's what gravitational force looks like. Both bodies will experience the same force. Okay? So as we are standing here on Earth, although the Earth is pulling us in, we are actually equally pulling the Earth towards us. Now, the reason why the Earth probably won't move is because there's so many other people on there, and the force that we're pulling the Earth with is so small that it won't really make a difference. Here's an example. Object A has a mass of 6 kilograms and object B has a mass of 9 kilograms. If the distance between the objects is 13 meters, what is the gravitational force placed on object A by object B? So Fg equals big G m1 m2 over r squared, which means Fg is going to be equal to 6.67 times 10 to the negative 11. Since m1 was 6 and m2 is 9, we're going to plug that in there. And since r is 13, we have 13 squared at the bottom. So you put all this in the calculator and you end up with your answer, 2.13 times 10 to the negative 11 newtons. All right, here's our last example. The moon has been struck by an asteroid. Oh no. Fortunately, the impact did not knock the moon out of its orbit around the Earth. If the Earth and the moon are still separated by a distance of 3.84 times 10 to the 8 meters, but gravitational force between the Earth and the moon is now 3.17 times 10 to the 20 newtons, what is the new lunar mass? Keep in mind the mass of Earth is 5.98 times 10 to the 24. So we have our equation, but instead of looking for Fg, we are now looking for m squared, which means we have to do a little bit of maneuvering in order to in order to get m squared by itself. So we're going to move everything else over except the m squared. So that means the r squared is going to go on top. The big G and the m1 is going to go at the bottom. And we're going to end up with fg r squared divided by big G m1 equals m2. So let's see what this looks like. That means that m2 is equal to the fg that we got in the problem, 3.17 times 10 to the 20, times r squared. R is 3.84 times 10 to the 8, but we have to square that. And we have at the bottom big G, which is 6.67 times 10 to the negative 11, times mass of the Earth, 5.98 times 10 to the 24. You plug all that in the calculator and we are finished. M squared equals 1.17 times 10 to the 23. Now if we moved a bit fast or anything like that, please remember you can go through the whole video, slow it down, pause, take notes, and everything can be at your speed. Alright, good luck.